In this question, we're asked how much power was necessary to embed the pellet into the block. The main ideas needed to solve this problem are the definitions of power and kinetic energy. Power is equal to the change in energy divided by the change in time. In this case, the change in energy is purely the change in kinetic energy. We're given delta T, so we'll find the kinetic energy of the system after the collision, and we'll find the kinetic energy of the system before the collision, and then use this expression here to find the power. The kinetic energy of the block and pellet after the collision is equal to 1/2 times the quantity, the mass of the block plus the mass of the pellet, times the velocity squared. This velocity we found in question 2, so substituting in the expression that we found there and plugging in the values given in the problem statement, we find that the kinetic energy of the system after the collision is equal to 100 joules. The kinetic energy of the system before the collision is simply equal to the kinetic energy of the pellet because the block is initially stationary. That means that the kinetic energy is equal to 1/2 times the mass of the pellet times the velocity of the pellet squared, where this velocity is the muzzle velocity which we found in question 2. Plugging in the values that we know and evaluating, we find that the kinetic energy of the system pre-collision is equal to 2,000 joules. All that's left now is to substitute in the values we found for the kinetic energy of the system post-collision and pre-collision, and the change in time between these two states, and evaluate. We do so here and find that the power necessary to embed the pellet was equal to 100 kilowatts.